Hi everyone, so this was Tuesday night's homework. We didn't go over it on Wednesday because we were filling out that paperwork, so here it is now. Okay, so this is question number 1. We have two functions and we're revolving around y equals -2. So the first thing we're going to do is graph this, and I graphed it by making a table. And we're going to have the y equals x squared is going to look like this. And the y equals 4x is going to look like this, and we're looking for this piece in here. Okay, so the 4x is the one on top, this is the one on the bottom. Okay, so just in general terms, we're looking for the volume, so it's going to be pi, the integral of the top squared minus the bottom squared dx. Okay, and so we're going to need our x interval, which we were not given. So we need to know what this x is and what this x is. So we're going to set the two functions equal to each other. And we see that we have x equals 0 and x equals 4. Okay, so we're going to put that in as our limits. Okay, we already said that the top function is 4x. And the bottom function is x squared. Okay, so far that looks good, but the one thing that we didn't think about is that it's revolving around the line y equals -2. It's not revolving around the y-axis. So y equals -2 would be somewhere down here. So it's revolving around this way. There's going to be a hole in the middle of all this, but it's revolving around the line y equals -2 and not the axes. So the rule that we have, this rule, is only for when we're revolving around the axes. So we have to get this back to the axes. So what do I have to add to -2 to get back to 0? I would have to add 2. So we have to add 2 to everything. So this will be our final answer. So here's the pi. We keep the 0 to 4. We still have 4x, but we're going to add 2. And we still have x squared, but we're going to add 2. So whenever you're going to revolve around a line other than the axes, you always have to say, how do I get it back to the axes? And in this case, you'd have to add 2 to get back to the axes. So this would be your final answer, and if you needed to evaluate that, you would. Okay, here's another problem similar to the previous one. So let's graph this first. So we have y equals x squared, that looks something like that. And then, I'll do different colors. Then we have the line x equals 2, that would be the orange one. Make another color. It's pink. Y equals 0 is this pink color over here. And so we're looking at this piece over here. So you can see that the x cubed is the one that's on top, and y equals 0 is the one that's on the bottom. And we're going around the line x equals 2. Now that means that we're revolving this way. So we're no longer doing top minus bottom. We're not going over the y-axis. We're going over this orange line. So how we're starting over here and going to here, so we have to go from the left to the right. So we're going to have left squared minus right squared dx. Okay, so this is what we're looking at so far. And we need our smallest x value, which is going to be over here at 0. And our biggest x value, which would be right here, which is going to be 2. Okay, and we have our pi. Alright, so we have pi from 0 to 2. The function on the left is the x cubed, and the function on the right is this orange line, which is x equals 2. Okay, so why is this wrong? Because we use dx when we're rotating over the x-axis. We're not doing that anymore. Now we're going to rotate around this orange line. Notice the orange line is parallel to the y-axis. So it's all really has to do with the y. So we can't use dx. So we have to change this to dy. That also means that that's going to change our limits here because we need the biggest and smallest y values. So our smallest y value is down here, which is 0, and our biggest y value is here. Okay, so what is that value? Well, we know that's when x equals 2. So if you put 2 into this function, 2 cubed is 8. So this would be the 0.28. So the highest limit would be 8. We still have a problem because you can't mix x's with y's. So we're going to have to change this up a little bit. Alright, so we know that the left function is definitely y equals x cubed. But we need to solve for x. So if I take the cube root of both sides, I'm going to get the cube root of y. Okay, so the cube root of y is my left squared minus my right squared. And my right is the x equals 2 dy. And so far that looks good, but there's one extra thing that we have to look at. Get another color. And that is we're going around the line x equals 2. So this would only be the answer if we were rotating around the x-axis, but we're not. I mean around the y-axis. We're going around the line x equals 2. So remember I said to get it back to 0, what would you have to do? You'd have to subtract 2. So our final answer will look like this. Cube root of y, and now we're going to subtract 2. We have 2, we're going to subtract 2, and that would be our final answer. And of course 2 minus 2 is 0, so you could simplify that more if you wanted to. Okay, so just keep in mind that whatever you're rotating around, if you have to add or subtract something, it goes inside the parentheses. Okay, here's the third problem. Okay, this is turning around the y-axis, so maybe this will be a little bit easier. So we have y equals x cubed plus x, and if you made a little table, you'd have a picture that looks something like that. And then we have x equals 2, so this is x equals 2 over here. And then we have y equals 0, so that's this over here. And we're talking about this region right in here. Okay, so we're going this way around the y-axis, so therefore we know we need y limits. We know we're going to be dy. We know we have a pi in front. And since we're starting on the right and going this way to the left, it's going to be the right squared minus the left squared. We don't have to worry about adding or subtracting anything in the parentheses because we're going around the y-axis. Okay, so we have pi. My smallest y is down here, which is 0. My highest y is going to be up here. And what is that value? Well, let's see. X is 2 here. So what is y when x is 2? Plug it in here, and you get 8 plus 2 is 10. This is the point 210. So we're going from 0 to 10. The right function is the yellow line, which is the 2, so we have 2 squared, minus the left function, which is our x cubed plus x squared dy. And hopefully you're going to notice that we have x's in here mixing with y's, and we're not allowed to do that. So let's do what we did before. We have y equals x cubed plus x, and we need to solve for x. And now this is a new problem because we can't solve for x. So what do you do if you have to go around the y-axis, but you can't solve for x? Okay, so this is something new. This is a bit of a problem. So I'm just going to write down when, so you know when to use this. So when, you should copy this, you must rotate around the y-axis but can't get the function into a x equals format, use the shell method. Okay, so this is a completely different way of doing it, and you use this when you have to go around the y-axis, but you can't get into the form x equals. Okay, so I'm going to show you how to use the shell method. There's a whole complicated way to explain this, but I'm just going to show you the easiest way to do it. And basically, instead of pi, you start with 2 pi. That's first of all. We want our biggest and smallest x. So our smallest x is 0, and our biggest x is 2. And now, instead of doing right to left, we do top minus bottom, because we're doing everything in terms of x. So our top function is x cubed plus x minus the bottom function, which is just 0, dx. But there's one other thing you have to add when you use the shell method, and that's an extra x here. Okay, so since we don't need that 0, we're going to end up with this. Okay, so in general, it's going to be 2 pi. These are going to be your x limits from a to b. You're going to have an x, and then you're just going to have the top function, dx. Now, you might say, why don't I have to do top function minus bottom function? When they give you these problems, it's always going to be a region that's going to sit on the axes like this. So there isn't going to be a top minus bottom, because the bottom is always going to be 0. Okay, so that's the shell method. Now, some people really like the shell method, and they like to use it when going around the y-axis, even if they can get it in the right form. And if you want to do that, you certainly can do that. Okay, here's the next sheet now. So this is question number 1. Here's our picture. Okay, so we have x squared will look like that. We have the y-axis will look like that. We have y equals 6, which will look like this. And we were told it has to be in the first quadrant, which means we're looking at this piece here. So we're going around the y-axis. Here's the y-axis. So in general, we're going to have pi. We're going to have our y limits. We're going to be doing right squared minus left squared dy. Okay, that's our goal. Okay, the smallest y value is 0. Our biggest y value is up here, which is 6. We were told that, 6. The function on the right is this piece right here. That comes from the y equals x squared. But I can't put x squared here because I have a y, and I can't mix x's with y's. So on the side, I'm just going to write y equals x squared, and now I'm going to solve for x. So x equals the square root of y. So the square root of y squared minus the function on the left is the red line, which is just x equals 0. So that would be 0 squared dy. And of course, you could simplify this to that. Okay, that one wasn't so bad. Okay, this was number 2, so our picture. So radical x plus 2 looks something like that. This is negative 2. And y equals e to the x is going to look something like that. How do I know this? Because I made tables, but this one would be a calculator question, because you're going to see you're going to have to solve something and it's not going to work for you if you don't have a calculator. Okay, so we're going around the line y equals negative 2. So let's say this line over here is y equals negative 2. So this region over here is going to rotate this way, so that's going to be a top minus bottom. So we have pi, our integral. We're going to have top squared minus the bottom squared dx. So let's start filling everything in. Okay, so here's why you're going to need your calculator, because what is the smallest x value? And what is the biggest x value from there to there? So you're going to put these two functions in your calculator under y1 and y2 to find out where they intersect. So you just have to go into second calc and do intersect, and you will find that they intersect at x equals negative 1.98097 and at x equals 0.4475. So that's these 2 points right here. Okay, so we're going to put them into our integral. Okay, our function on the top was this one over here. Minus our bottom is this one. But we're not done. This is not complete because, let me do another color. We are rotating around y equals -2. So to get back to 0, we're going to have to add 2 to each parentheses. And our final answer should look like this. Pi, here's our integral with these crazy numbers. Okay, here's my first parentheses, and I'm going to add 2. And here's my second parentheses, and I'm going to add 2. And that is my answer. Okay, and this is the final problem. So first let's graph this. Okay, so 1 over x. Well, I made a table, and I used the values from 1 to 4, because that's what we were given. Let me use another color. Okay, so x equals 1 is here. So x equals 1. X equals 4 is here. Y equals 0 is here. And 1 over x in between the values 1 through 4 is going to look something like that. So we're looking for this shaded area here, and this one is going about the y-axis, so this way. So it's a right minus left. So we have pi, doing everything in terms of y. We're going to have right squared minus left squared dy. So now we just have to fill that in. Okay, our smallest y value is 0, and we need to find what is our biggest y value, and that's going to be right there. And wait, I just realized this question said do it using the shell method, but I'm going to finish this anyway, and then I'll do the shell method. So how can we figure out what that point is? It's the intersection where x equals 1 and 1 over x meet. So I'm just going to put the 1 over 1 and cross multiply, and I get x equals 1. So my y value is 1. My function on the right is over here. This is my x equals 4. So 4 squared minus, this is my function on the left over here, which is going to be my 1 squared dy. Okay, so you might say, what's the matter with this problem? Well, what's the matter with it is that we never used the function 1 over x in any of this. So how would this integral be able to give us the volume? That's an issue. So this is why they asked us to use the shell method, and that's what we're going to do. But I just wanted to show you what would happen if you just kind of went with it and did it the other way. Because sometimes they're not going to say use the shell method, and you're not going to know. Okay, so to use the shell method, we start with 2 pi. We need our interval in terms of x, so that's going to be from 1 to 4. That's these right here. We have an x. That's what you're always going to add is the x. And then we're going to do a top minus bottom. So top is 1 over x. the bottom is just 0, so I don't have to do that, dx. And we could simplify, because x times 1 over x is just going to become 1 dx. This will be real easy to solve, so I'll go ahead and solve it. So the antiderivative of 1 is just going to be x as it goes from 1 to 4. So we get 2 pi times 4 minus 1. So 4 minus 1 is 3, and we're going to get 6 pi. So that would be a non-calculator, pretty easy one for you to calculate. And that's it for the homework.